I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So guys, you know this is a 60 mark series going on, and this is the first session of strength of material, which is common for actually both mechanical and civil the subject. So guys, please tell me, am I properly audible and visible to all of you or not, and do like and share the session so that other students can also join. Yes, Kalyan, am I properly audible? Please tell me that. Then we are starting the session. So guys, this series is in English purely. Okay, this is not bilingual, this is for purely English. And guys, as I already told you that in this series we are going to discuss some wonderful problems of some of the important topics which generally every time comes in the examination. Kiran, good evening. Midun, good evening. Arun, yes, hello dear. Kalyan, yes, fine. Ayush, hi dear. So we are starting the session. So as you can see, the heading is simple stresses and strain. So in this heading, simple stresses and strain, what are the important topics from which questions are majorly coming? Rishikesh, yes, good. So one is stress strain diagram. Second, bars in series, bars in parallel. Okay, these are the major topics which are coming. But to make it slightly more, I will say that variety problems, I have taken 1 to 2 problems from bending as well to make it a more quality session, because there are some things which are coming every year in the exam. Those things we must do. So we are starting the session. Good evening, Rishikesh. So guys, let us start the session. So moving further, first of all, this is some detail about me. Those who are watching me for the first time, my name is Dheeraj Sir. I am having around 10 plus years of experience, and today's subject is strength of materials. Then guys, the small information about the workshop. We are starting in 1 minute. Okay. So this is a mega workshop would be there by Abhinav Negi sir. He is an expert, and guys, this workshop is related to get step-by-step guidance to go from a beginner to GATE topper. It would be on 19th of November at 8 p.m. So guys, if you are a 2024 aspirant, this is going to be a wonderful thing for you. You can join it, and for that you can register in the description also. Yes, Tushar, hello dear. So moving further guys, yes, so this is an information related to that. If you want to download the free ebook related to GATE preparation, that is available in the description box of the session. And other than that, if you are looking for scholarship, then scholarship test link is also there in the same description box. And third thing, as I already told you, that if you want to register for the workshop, that link is also there. So guys, now we are moving to the question number 1 without wasting your time. This is the question from bars in series. So as I told you, it is an important topic. This is the question from bars in series. So you can see they have given this bar 1 and bar 2 in the series. Both are of circular cross section. They have mentioned their diameters 10 mm and 15 mm. 25 kilonewton is force that is acting here. R1 and R2 are the support reaction. They have even given you the directions of theirs. So you need to find out the value of R1 and R2 when their lengths are also given to you, and this is the 1 mm permitted elongation. Okay guys, so this type of question previously have already been asked in XC paper and also in mechanical and civil engineering services papers also. So this is a very important type. Yes, sir. No, this is not marathon, Kalyan. Here we are going to discuss the problems. Actually, this is the series where we are discussing some good questions. 60 mark series where some important topics questions are being discussed. Yes. So just like the session, share it with your friend and subscribe the channel if you have not done yet, because all the mechanical civil sessions would be there on this channel only. So guys, just try to solve it. If you want, I can give you hint. Like this is bar number 1 and this is bar number 2. So you can see permitted elongation is given as 1 mm. So we can write delta of 1 plus delta of 2 is equals to 1 mm. So you can use this. What is delta of 1? We can write P1 L1 upon A1 E1. Then what is delta of 2? We can write P2 L2 upon A2 E2. Okay guys, it is equals to 1 mm. Then my dear, you would be applying the method of section to find out P1 and P2. So when you will be applying the method of section to find out P1 and P2, you can see it is away from the section. Away from the section means tensile. So P1 is plus RA. Okay. Similarly, when you are going to find out P2, then you will be taking section here. This is tensile, this is compressive. So you will be writing plus RA minus 25,000 because it is in kilonewton. So I have given you these values. Length are given, areas, diameter are given. Young's modulus is also mentioned. Apply the formula, get the answer. Yes, Ayush, Kalyan, Tushar, everyone guys, just solve it. I want answer from all of you. Yes. Are you trying guys? Just tell me that and try to solve it. Yes guys. Solve it, and when you are answered. Yes. Very good. I feel I got answer from one of the student. Aditya is saying 10 kilonewton and 15 kilonewton. Aditya, please check it. I feel you have made some mistake. Just check it. Okay, this is the equation we are going to use. From here you will be getting the value of RA. And after getting that value, you can also write this RA, or you can call it as R1, because we are putting RA as R1 only. Okay. So this is, I am writing RA. So RA and R1 are same. So you can write RA plus RD, which is also equals to R1 plus R2. That is equals to, you can see this is upward, this is upward, this is downward. It is equals to 25 kilonewton. Yes. Anybody else? Yes, Aditya, that's what I want to say. If you will not take this 1 mm into consideration, then your answer is correct. But that is not the right way to solve it, okay? Because it is the case of permitted elongation, guys. So just solve it, guys. I want answer from your side. I want the answer because this type of question is coming in the GATE examination nearly alternate years, or you can say in other examinations like ESE also. So it is going to be helpful for all the examinations. Yes, solve it and give me the answer. And just like and share the session, guys. There are some wonderful questions. That's why I am giving you time also to solve it. Okay. So as I already told you, now from now onwards, all mechanical session of English, Hindi, both languages, also related to XC, all sessions would be on only this channel. Okay. Yes. So definitely, if you have not subscribed yet, just do that. Yes, Aditya, Kalyan, Ayush, कहाँ है भाई सब लोग? ज्यादा लेंदी हो गया क्वेश्चन? Yes, बताइए. Just you need to put the values. This is L1, this is L2. Put it and give the answer. Once again, Kalyan is giving the same answer. Yes, Aditya, have you done it now? Okay, Midun is saying 7.45. So dear, I have already given you the hint. Let us put the value. Okay, when you will be putting the value, you have written R1. And what is the length? If you see, the length is 1000 mm here and 1500 here. So you will say into 1000. And pi by 4, 10 ka square. And 200 into 10 to the power 3. Plus, next is R1 minus 25,000. If you are taking it in Newton, then my dear, into the length is 1500 divided by pi by 4. 15 ka square into 200 into 10 to the power 3. It is 1 mm. Okay. Very good. So guys, when you will be solving this, okay, different answers are coming. I feel Kiran Kumar have given the right answer. So R1 will be coming out to be 19.43. So Kiran have given the right answer. 19.43 kilonewton. And R2 will be coming out to be on the similar note when you will solve it. It is coming out to be 5.57. 5.57 kilonewton. So these are the answers for this question, guys. I feel have given the right answer. Dear, whatever the mistake you have made, here I have put it in mm. Why? Because I am taking everything is Newton per mm square. That is why. And why I have converted kilonewton into Newton? The same reason. Because I am taking everything in Newton per mm square. So I feel now you are getting it. This is the first question. And if you are making mistake, don't worry. Because you will get to know what kind of mistakes you can make in exam and you can rectify that. Is it clear? Very good, Kiran. Very good. So guys, shall we move on to the second question now? Shall we move on to the second question now? Are you ready for the same? Yes. Moving to the second question. Okay. First, let us do this question from thermal. Then I'm having a surprise question for all of you. Very new type of question, never been asked in SOM. But first, do this question. This is a question from thermal stresses. I will give you the hint also. He is saying a bar AB of length L is held between the rigid support. So first of all, this is the bar which is held in rigid support. When it is held in rigid support, what do you mean by that? Neither bar can expand from here nor from here. So you can say one thing, that delta of the bar is going to be 0. Okay? Then my dear, he is saying that it is heating non-uniformly in such a manner that there is a temperature difference, and that is a function of x like this. So whenever temperature is increasing, this bar will be having a tendency to increase in size. Because of that, thermal expansion will happen. You know, delta thermal is given as L alpha delta T. But this time delta T is a function of x, my dear. Okay? So whenever it is a function of x, it is variable from A to B when we are moving. So guys, for this case, we need to consider a small part. We need to consider a small part of dx length. Okay? So it is already mentioned how delta T is related to this. Okay? So we are considering this small part of dx length, and we will be calculating the delta thermal for this first of all. So here length is dx. Okay, so delta thermal, when you are going to find out for small part, it is going to be dx into alpha. And what is delta T? This is delta TB. I'm giving you the hint, so don't worry. This type of question you will have in GATE examination, divided by L cube. So from here you can find out by integration delta thermal total. That would be expansion because of the temperature, guys. After that, he is saying that derive a formula for the compressive stress sigma C in the bar. Now this expansion would happen if this bar is free from the end. But you know, here some reaction will be generated at the support. Okay. So because of that, some stresses would be coming. So you can write the axial compression is equals to, that is RL upon A. Okay, so you know this is going to be negative. Why? Because it will try to cause the compression. Then my dear, you know delta total is going to be 0. So delta total is equals to delta thermal plus delta axial is equals to 0. So delta thermal is equals to minus delta of axial. So minus delta of axial is minus R L upon A. It was already minus. So minus R by A, minus minus will become plus. This is sigma C into L upon E. And here you will be calculating delta thermal. Equating these two things, you can find out the expression for compressive stresses. So I am showing you guys, I am showing you the previous slide. You can start it like this. Integration will give you the total thermal expansion. This is a very good question, guys. Okay, I already told you in this session, we are going to prepare you in such a way that some new type of questions will be coming. It is not for the PYQ session. Very good quality questions would be there. Yes, Kiran, Shreyash, Arun. solve it. And as I already said, don't run from these problems. Okay, I am not here to solve a question like force is given, area is given, find out stress. That will not come in paper. Okay, so be ready for such problems, so that if question comes from these topics, we can score well. I have given you the hint already. And guys, just like the session so that other student can also reach here. I already told you, you just need to integrate this. When you will integrate this, alpha is constant, delta TB is constant, L cube is constant. What you will be getting? Delta thermal total. You will be getting, yes, alpha will be as it is, delta TB will be as it is, X cube will become L4 by 4, L4 by 4, L cube. So L cube will get cancelled out by this. It is alpha delta T L by 4. Very good. I feel answer have come. Very good, Vineet. बहुत ही बढ़िया. Alpha delta TB L by 4. Alpha delta TB L by 4. It is, you need to find out this. This is alpha delta TB L by 4. You need to equate this with sigma C. L will get cancelled out. Okay, and you would be getting the answer to be E alpha delta TB by 4. Just look at it. Very good. I feel Kiran have done it. Arun have done it. बहुत ही बढ़िया. बहुत ही बढ़िया. So guys, you can see the solution once again if you want. And please tell me you got it or not. If you will say yes, I will move to the next problem. Tell me once again. Any doubt? Please tell. Yes, very good, Manas. बहुत ही शानदार. बहुत ही बढ़िया. Moving to the next problem, guys. Now I am coming with a very new type of problem. I already told you this is a surprise problem for you. And in this problem, it is mentioned that this is 2 into 1 plus epsilon y, and it is 1 into 1 plus epsilon x. You can see there is a member in this question. Very good, Aditya. This is the member. Very good, Rishikesh. So in this member, the stresses are acting like sigma. Sigma. Okay, this is like this. These are the stresses. And on this, we have plotted a line like this. And this line is plotted in such a way that this and this, if I call it as y, if I call it as x, then it is mentioned that y by x is equals to 2. It is given to you. This is given to us. Okay. Sorry, this is not given to us. Actually, I would like to say, let us first of all see the question, then I will tell you what they have given. Okay, let us start it once again. Look at the question, guys. An aluminium plate is subjected to a centric axial load which causes a normal stress sigma as shown in the figure. Before the loading, a line of slope 2:1 is scribed, and in that this is mentioned as 2 into 1 plus epsilon y, 1 plus epsilon x. This is mentioned. And then they are saying sigma value is 125 MPa. They are asking the slope of this line. So, if this is the theta, everybody knows slope is given by tangent theta. Very good, Kalyan. Slope is given by tangent theta. So, the slope of this line can be written as tangent theta is equals to 2 into 1 plus epsilon y divided by 1 plus epsilon x. Now, my dear, this is a uniaxial loading. You can see this. It is a uniaxial loading. You can see this. So, if someone asks you what would be epsilon xx, you will say it is sigma xx upon E. Okay, because sigma yy is 0, you can say here sigma xx is equals to sigma, and sigma yy is 0 because it is a case of uniaxial loading. Then, my dear, epsilon yy, if you are going to find out, it would be sigma yy is 0, so minus mu times sigma xx upon E. So you can see sigma xx is nothing but sigma, and sigma yy is nothing but 0. So if you see these two values, mu is given to us, E is given to us. Just put the value, you will get epsilon x, epsilon y. Put these values, you will be getting the value of theta. Okay, because you need to find out the slope, so you need to find out the tangent theta. So you just need to find out this tangent theta. Solve it and get the answer. Yes, Vineet, are you giving the answer for this question? Yes. Solve this question, guys. I need answer from your side. You guys have asked me on that day when we were starting this session, this series. You said, sir, all the questions should be new. We don't want the questions of monsoon series. We don't want the questions of the previous series. Every question is new. Okay. Now you have to work hard because questions are new. Okay, solve it. Okay, Vineet have said the answer to be C. Okay, what about others? What about others? Okay. Midun is saying A. Midun is saying A. Fine. Yes. Kalyan is saying 0.1995. So Kalyan is also saying C. You just need to find out epsilon xx, epsilon yy, put the values here, you will get the answer. Yes, once again check it, Midun. Once again check it. Manas is also saying A. Okay. I feel for A, polls are more now. What you are getting as epsilon xx, can you tell me? Are we getting epsilon xx as equals to, it is coming out to be what? 1.6892. 1.6892 into 10 to the power minus 3. And when you are finding out epsilon y, we are going to get the values to be minus 0.5574 into 10 to the power minus 3. Are we getting these values? Please tell me that. Okay, Jabir, very good. Fine, fine, fine. So when you get these values, when you will be putting the values, I feel you will be getting the answer to be A 1.995. So A is going to be the right answer. Very good, Aditya. Very good, Jabir. I'm really happy that you are able to solve such type of problems. That's really great because they are some new types of problem. I feel you also agreed that, have you seen this type of problem before? Yes. Next question. This is slightly easy question because every question in GATE would not be difficult. Okay. So I am expecting you will be giving right answer for this also. So here they have given you the value for strain matrix. This is a 3 cross 3. They are asking you the shear modulus. This time I am not going to help you even. Okay. So I am expecting you will give the right answer for this problem. Wonderful, guys. तो लाइक करने में इतना संकोच क्यों हो रहा है यार? लाइक तो करो. नए क्वेश्चन भी है, अच्छे भी लग रहे हैं सर, पर लाइक नहीं करेंगे. Like the session so that others can also join. This is an appreciation. Yes. Solve it. So guys, tau is given as G times of gamma. You need to use this relation. Okay. Solve it. Solve it, guys. Solve it. Yes. You know, here they have mentioned the shear stress. Okay, you need to find out tau and you need to take gamma from this matrix. Jabir is saying B. What about others? B. Aditya B. Nora Fatehi also is saying B. Vineet is saying B. Kiran is saying B. So guys, I feel you understand here gamma by 2 because this term is gamma by 2. This is nothing but 0.005. From here we can write gamma is 0.010. If you put this value here, G would be tau by gamma. So answer will be 100 GPa. So answer for this session, this question is B. So I feel the answer is B. Actually, you have make this mistake that this is not gamma, this is gamma by 2. I feel I have explained a number of times. This matrix is written like this. epsilon xx gamma xy by 2, gamma xz by 2, then gamma yx by 2, then epsilon yy, then gamma yz by 2. Okay, similarly gamma zx by 2, gamma zy by 2, and it is epsilon zz. I also told you why this matrix is coming in this way. We have made a wonderful discussion over it many times. Very good, Rishikesh, the answer is correct. Moving to the next question, guys. So this time, guys, just to make it a session with variety problems, as per your request, I added 2 to 3 questions from bending, but I will help you for that. This is the question. A beam of unsymmetrical I section made of structural steel has overall depth of 300 mm. If flange stresses developed at top and bottom are 1200 and 300. So I am showing you the stress distribution. At the top, stress is 1200. Okay, at bottom, stress is 300. So this is going to be the stress distribution. This is 300. Units are mentioned as kg per centimeter square. Kg per centimeter square. They are asking you what? The total depth they have mentioned is 300 mm. Total depth is 300 mm. Total depth is 300 mm. So you need to find out the distance from the top fiber to the neutral axis. Assume it x. Try to find out. This is very easy question, I feel so. Vineet is answering as B. Kiran is also saying I feel 240 means B. Yes, I need answer from all of you guys. These sessions are similar to the GATE pattern. In GATE, you will find 1 to 2 questions which are going to be very hard. Other questions would be normal level. So in every session, I would be having 2 to 3 such questions you have never seen. And rest questions would be either at the level of GATE or slightly above. There would be no question below the GATE. Okay? Okay, it's fine. So this type of question comes. So I have taken. Jabir is saying B, Rishikesh B, Kiran B, Vineet B. Rest I am waiting for others. Mani, Ayush, where are you guys? Kalyan, Midun, very good. Aditya, हाँ बहुत बढ़िया. Manas, बहुत बढ़िया. So you guys are really doing well. So there are 2 ways to solve it. One way is similar triangle. You can see this is 90, this is 90. Okay? This angle and this angle are same. So by angle similarity, because 2 are same, third would be same. Angle similarity, you can say 1200 by x. 1200 by x is equals to 300 by 300 minus x. This is the one way, and you will get x to be 240 mm. The second way is apply the bending stress. You know from the derivation, strain is directly proportional to y. So if strain is directly proportional to y, stress is also directly proportional to y because Hooke's law is valid. So you can write sigma top bate sigma bottom, y top bate y bottom. You will get the same equation again. So the answer will be coming out to be same once again. B would be the right answer. Very good. Arun, Jinil, welcome to this session. बहुत दिनों बाद, महीनों बाद दिखे हो. अब रेगुलर रहा करो, यही कहूंगा मैं तो. ठीक है, रेगुलर रहोगे तो आपकी जो तैयारी है वो आपके काम आएगी, नहीं तो it would not be used. This is the only question from thermal I have taken from PYQ, only one question. The reason is this is the question where majority of the students have doubt. So to clarify their doubt and to tell you the way to solve the thermal problems, I have taken this. Okay, so to make this session easy for all those who have not practiced much on thermal, I have taken this question. Yes. Try to answer it. Otherwise, I will help you. सर मैं ट्राई नहीं कर रहा. हाँ कोई बात नहीं जाबिर, थर्मल नहीं कर रहे तो 1-2 क्वेश्चंस हैं. ओके, नोरा इज सेइंग बी, कल्याण इज सेइंग बी. Vineet is saying B. Kiran is saying B. बहुत बढ़िया, बहुत ही बढ़िया. So I feel majority of you have given the answer. I am telling you how to solve it. So guys, first of all, when we have the thermal stresses problem, there are two things acting. Yes, Naveen, very good. She asked, very good. There are two things which are acting. One is the effect of temperature causes thermal stresses. Second is the effect of forces or reactions comes in the form of, yes, mechanical stresses, or you can say mechanical or civil. So guys, we need to understand both of them separately first, and then we need to take the superposition of theirs. So they are saying a square plate of side A, rigidly held at three edges, is free to move along the fourth. So you can feel we have a square member whose three sides are rigidly held. So it is free to move in this direction. And he is saying that T is the change of temperature. Then you need to find out the free expansion at the fourth edge. So my dear, now as I said, there are two things. One is thermal, other is mechanical or civil. So let us see. This is the member I am showing you once again here. A is the side. It is fixed from three sides. So I am assuming that we need to talk about the two stresses. Here I am making the diagrams. Here I am writing strain in x-x direction. Here I am writing strain in y-y direction. So just see. Let us say if this member is not fixed at three sides, and I am assuming this member is free from all the sides. So my dear, when this member will be free from all the sides, you know there is a change of temperature. So because of this change of temperature, it would be having an increase of size. This is said to be free thermal expansion. And you know, because of this, when we find out the stress, that comes out to be alpha delta T. How alpha delta T? You know delta L is L alpha delta T. The side is A. So I will write delta A alpha delta T. So if you will find out the strain in x-x direction, delta A by A, it will be alpha delta T. The same y side also the direction is same. So it is also alpha delta T. This would be the answer if free expansion is happening. Means if we are not fixing it from any of the end. But my dear, as we have fixed it at ends, so what the ends will do? As in this direction both sides support is there, reaction will come to maintain the body in equilibrium, because it will try to expand, both side reaction will come. Here my dear, when it will try to expand, here there is no reaction. Here if you write the reaction will be zero. Why? Because expansion is permitted in this way. So the member will expand from here. Why? He will have fight with the support. If you have one side wall, one side gate, you will directly go out from gate. Why you will have a fight with the wall? So material will be getting expanded from here. So you know that expansion would be happening. Why? What are the reasons? So you have stopped the expansions in this direction. So if temperature would be alone, alpha delta T would be the expansion. But when it is fixed from both the side, net expansion in this direction would be zero. So if this is alpha delta T, because of this force reaction R, here it must be minus alpha delta T, then only you would be having the net zero out of these two. And you have studied the epsilon YY is given as minus mu times epsilon XX, which will be minus mu times, this is minus alpha delta T. So it would be coming out to be mu times alpha delta T. Lateral is mu times longitudinal. So when you would be having the addition of these two, you would be having 1 plus mu alpha delta T. I feel everybody understood, those who know the concept of thermal stresses. So guys, the answer for this is going to be B, no doubt about that. Okay, let us move to the next question. Naveen, Kiran, Vineet. Let us see the next question. This is from first chapter, simple stresses and strains. The question is a circular bar of diameter 50 mm is subjected to a pull of 50 kilonewton. The elongation in the length was recorded. Delta L is 0.090 and they are saying the reduction in diameter. Delta D is minus 0.06. Okay, all these are in mm. You need to find out Poisson ratio and other, or 250 mm is the total length. So this is the easy question. Rishikesh, Shreyash, Naveen, Kiran, Vineet, Nora, Kalyan, Jabir, Arun, Jinil, everyone can solve this question. I will tell you how to solve it. You know delta L can also be written as PL upon AE. Okay, they have mentioned you 50 kilonewton. Area is mentioned to you. Okay, and they have also given you the length. So my dear, when you will be equating this and this, 0.09 PL upon AE, this will give you the value of Young's modulus. Okay, this will give you the value of Young's modulus. Then my dear, you know that longitudinal strain is delta L by L. Lateral strain is delta D by D. And Poisson ratio is minus lateral strain but a longitudinal strain. You will get the Poisson ratio. And after getting 2 elastic modulus, you know E is equals to 2G, 1 plus mu. And it is equals to 3K, 1 minus 2 mu. After getting 2 modulus, you can find out other two also. So just try to calculate the values one by one. First I want Young's modulus, then I want Poisson ratio, then I want G, and then I want K. Solve it. Question is there on the screen. Hint is there on the screen. One by one you can give the values, guys. Okay, this is a wonderful question and I will be sharing the PDF of this session on to the Telegram channel Mechanical by Dheeraj Sir. You can join it. Okay, solve this question. Yes, solve this question, guys. Everyone. Solve it, guys. Any answer, guys? Yes, Rishikesh, Naveen, Kiran, Vineet, Nora, Kalyan, Jabir. What would be the answer? What we are getting as Young's modulus, load is 50 kilonewton, diameter is 50 mm, length is 250 mm. Yes, guys. Very good, Kiran. So Kiran have given the value of E. So when you will find out the value of E, E will be coming out to be 7.07 into 10 to the power 4. Very good, Naveen. Very good, Kiran. It's fine. The answer is correct. Dear, it will not be coming in terms of mu. It is 0.09. Okay, this is 0.09 already in mm. Okay, this length is also in mm. Mm will get cancelled out. Okay, so the answer of E will be coming out to be 7.07 into 10 to the power 4. Very good, Arun. Very good, Vineet. Poisson ratio would be coming out to be 0.33. 0.33. Okay, 0.33. Very good, Arun. Vineet, बहुत ही बढ़िया. Kalyan, I feel you have made some small mistake. Yes, Naveen, Shiash, Rishikesh. After getting mu, we need to find out the value of G now. G and K. G and K. Okay, G also Kiran have given. I'm telling you it is coming out to be 1. I feel Kiran G you need to check it. Okay, 2.65 into 10 power 4. Very good, it is correct. It is correct. Let us write it. G is 2.65 into 10 to the power 4. And similarly you can find out K. And K will be coming out to be 6.93. 6.93 into 10 to the power 4. So I feel wonderfully you have solved it, guys. Maza aa gaya. It's a really nice sign the way you are solving. Now guys, we are having this a very wonderful problem from thermal stress once again. Sir, power mistake happened. It's fine. So dear, this is the case where they are saying there is a cube. There is a cube and they are saying each side of the cube is resisted by sigma. So each side of the cube is resisted by sigma. This is what they are saying. And guys, they have also mentioned that temperature is raised by T degrees Celsius. Temperature is raised by T degrees Celsius. And they are asking you the value of sigma when temperature will be raised by T degrees Celsius. I already told you, whenever you have a question from the thermal stresses, you need to find out here volumetric strain, because there are 3 dimensions, due to thermal. Okay, you will find out volumetric strain due to thermal. Then you will find out volumetric strain because of sigma. And you need to add them and equate to 0. Why? Because overall there is no strain happening. Because the body is restricted from all the sides. So just solve it. I feel some of you have given the answer. This is a famous question. Kiran is saying B, Kalyan is saying B, Vineet is saying B. So alpha TE by 1 minus 2 mu is the answer given by you. Any other, if you want to answer, please answer it. Then I will solve it for you guys. Wonderful. So guys, next session of mine would be on Friday. That is on the Mohr circle. And I'm going to take all the varieties of the Mohr circle problems. All the varieties which are possible. So don't miss that session. There you are going to learn the new varieties, new types of questions. And it is going to be very, very interesting session. So don't miss it. Okay. We are left with 2 more questions for this session, 1 to 2. So let us see how to do this. You know, because of when we are talking about volumetric strain, because of temperature, you will write it as XX for cubical body, XX plus YY plus ZZ. Just now we have seen strain is alpha delta T plus alpha delta T plus alpha delta T. So it is 3 alpha delta T. This is tensile, so it is going to be positive. Then you know, because of sigma, because of force, volumetric strain is given as 1 minus 2 mu upon E. It is given as sigma XX plus sigma YY plus sigma ZZ. This is the formula we derived in the first chapter. All stresses are compressive in nature. You will write it as 1 minus 2 mu divided by E into minus sigma minus sigma minus sigma. It is 1 minus 2 mu upon E into minus of 3 sigma. Now you know this is compressive and this is tensile. And overall it is going to be 0. I will check it beneath. Okay. So when you will say net volumetric strain is 0, that is the summation of both 3 alpha delta T plus it is 1 minus 2 mu upon E minus 3 sigma is equals to 0. When you will do this, guys, this negative term will be going on the other side and we would be having 3 alpha delta T 1 minus 2 mu upon E 3 times of sigma. 3 will get cancelled out and sigma will be E alpha delta T by 1 minus 2 mu. This would be the value of the stress. I hope you are getting it. Yes, Vineet. So guys, this is my sincere request. This topic is still simple. Next topic, Mohr circle. Don't miss those variety of problems. Dear Vineet, it is the best book, but this is not the time to study that book. Okay? This is not the time to study that book. That is the point. This is the question from stress strain diagram now. We are having a diagram in which here it is stress, here it is strain is mentioned. And they are asking you the resilience and toughness. But the units are Newton meter per meter cube. So in other words, they are asking you modulus of resilience and modulus of toughness. Just try to solve it. Here the options are R, S, T, U. Okay, so don't get confused by that. Solve it, guys. Okay, Vineet, then you have enough time. You can go for it. Wonderful, Vineet. So solve this question, guys. This type of question I have done a lot of time for you, and this is from stress strain diagram. We need to find out the resilience, not resilience, modulus of resilience. Because resilience is in Newton meter. Energy is in joule. Per meter cube means what? It is resilience but a volume, which is modulus of resilience. Modulus of resilience is given by this area. Okay, so you need to find out this area. This area is modulus of resilience. Okay, and if you want to find out modulus of toughness, then this entire area is modulus of toughness. Okay, so try to solve it. Let us see how many of you give the right answer. Solve it, guys. Manas. Yes, Dipanshu. Sorry if you are finding any difficulty. Sorry for that. So guys, what is the right answer? T. Okay. T. T. People are saying T. Okay. So my dear, when we are going to find out the modulus of resilience, it is the strain energy per unit volume stored by the material up to elastic limit. You know this is the elastic limit. It is mentioned. So you can see modulus of resilience will be area of triangle 1 by 2 into 70 into 0.004. So when you will solve it, you will be getting 14. Okay. And as this 17 MPa, so 10 to the power 6 you will be doing. So answer will be 14 into 10 to the power 4. This is modulus of resilience. You can see only one option have this value. So answer will be T. Still, if you want to find out modulus of toughness, it is the area of triangle plus area of rectangle. Sorry, area of triangle plus area of this rectangle plus triangle. Or you can take it as trapezoid. So if you will take it as trapezoid, it will be 1 by 2, 70 plus 120 into 0.008. So when you will be having this plus modulus of resilience, total area, the answer will be coming out to be 90 into 10 to the power 4. This is going to be the answer. Yes. So guys, anybody else is also facing any sound issue? Maybe the mic is not properly. That's why I was asking, am I properly audible and visible to all of you or not? Please tell me. Voice is coming nicely or not? This is the last question for today's class. I will see, Vineet. I will try to provide my handouts. If this is the question from civil services prelims, this is the most important question. Yes, from the bending. They are asking you about the strain tensor for the bending. They are asking you for the strain tensor. Strain tensor for pure bending. Strain tensor for pure bending. Strain tensor for pure bending. Last question for today, guys. Do like and share the session, guys. This is the first session of 60 mark series. Kalyan have given the answer to be C. Yes, Manas. She asked. Kalyan is saying C. Kiran is saying C. Very good, Kiran. This is the last question of the class. Or if you want, I have one more question for you. I will give you as a homework if you want. Sure, Vineet, I will provide that. Rishikesh, very good, dear. She asked, very good. Yes, Dipanshu, are you there? Fine. So guys, let us see what is going to happen in the pure bending. So we are having this a beam. And on this beam, we are having a bending couple like this. This is the longitudinal axis. So you know, whenever we are talking about this, we would be having the cross section, let us say rectangular like this. This is the neutral axis. You know, when bending couple is acting like this, my dear, top fibers are under compression, bottom fibers are under tension. So if you are going to see the stress distribution, I will show you the stress distribution is going to be like this. Like this. Top fiber compression, bottom fiber tension. Kalyan, don't worry. Actually, already your 2 subjects are going on, so I will be coming for that. Don't worry. On the Sundays, we are planning from the next Sunday. Because we cannot skip the other subjects which are in between. Don't worry about that. So we are going to have this, and you know, my dear, if we are going to write the strain tensor, pure bending is the condition. Pure bending is the condition when shear force is becoming 0. So because of that, when you will be writing the strain tensor, it is for sure. Here you would be having some epsilon xx, here some epsilon yy, here some epsilon zz. Rest is going to be 0, 0, 0, 0, 0 and 0. Then you also know this is a uniaxial loading. Pure bending is the uniaxial loading. Uniaxial means if you want to see the state of stress of this point, you would be showing it in this way. So for uniaxial loading, we can write epsilon yy to be minus mu times epsilon xx. So we can write this epsilon yy as minus mu times epsilon xx. This is also minus mu times of epsilon xx. So you can see these two values are equal. So you need to see which one of the option is following this condition. You know, here these two are not equal. Here all three are equal. So this is wrong, this is wrong. Here this is 0, this is wrong. We are having this as right because these two are equal and this is different. Here you can say Q would be minus mu times of P. Okay. So this is the beauty. सर डिजाइन में ईएम पूरा और एमडी के 1-2 टॉपिक बाकी है, तो अभी मैं कैसी स्ट्रेटजी रखूं? टॉम और सोम में तो एमए टेस्ट सीरीज भी दे रहा हूं. बहुत बढ़िया विनीत, इसके लिए अपन अलग से बात कर लेंगे. आई फील वी कैन कनेक्ट ऑन टेलीग्राम एंड व्हाट्सएप. देयर आई विल सजेस्ट यू. ओके. सो मानस, वेरी गुड. द आंसर इज डी. नाउ गाइस, डू यू वांट 1 to 2 more question? I have. Okay, if you want, we can do. Okay. This is the question I am giving you for homework, and you need to answer in my Telegram channel or WhatsApp. Okay, this is the homework question, and I will be sharing the solution of this question onto the Telegram channel. We need tomorrow in the first half before 1 p.m. from 10 a.m. to 1 p.m. Okay, this is the case. This is the question. This is homework question. And I have one more homework question for you. This. Try both the questions. I would be giving the solutions on the Telegram channel of these two questions. And the PDF of this session is also coming on the Telegram channel. The name of the Telegram channel is Mechanical by Dheeraj Sir. Just join that group. You will get PDF of this session. And you have to submit the questions of these two solution of these two questions in either Telegram, or you can write the answer in the comment section. Those students who would be giving the answer, I will mention their name in the next session. Okay, next session is related to Mohr circle, and I'm telling you, you are going to see some very new type of question you have never seen before. So be ready for that session. It is on Friday, and tomorrow there is a session in the Hindi series. Those who are the student who are okay with Hindi language, they can come for the thermal science session of Sonu sir. So on alternate, one day English, one day Hindi is going on. So Monday, Wednesday, Friday is for English, Tuesday, Thursday, Saturday is for Hindi. On Hindi, thermal is going on, English SOM is going on. Sure, Vineet, I will share that. I will surely share that. So goodbye guys for this session. Thanks for joining and thanks for your love and support. So we are meeting on Friday once again on the same time, on the same channel. Do subscribe if you have not done yet. Goodbye.